Our next speaker is Vince Newmeyer. Now, if you don't know Vince, Vince has been leading the battle in Utah against bad science. Some of the things that have been enshrined in like next generation science standards and things of this nature. Vince is kind of the lone voice in the wilderness at times, but I'm really glad he's there doing it. And he's got some other individuals that help out a lot with it, but Vince today, he's got a great presentation, a great eye-opening set of facts he's going to talk about. The title of his presentation is Science Theories Are Not Science Facts, and I think we're all going to be well educated. So please welcome Vince Newmeyer.
You don't even understand the definition of a scientific theory. Well, such was the accusation hurled at me as I sat on the Science Standards Committee for the state of Utah. This professor, an educator in biology, turned to me and said these words and continued. A scientific theory means there's no evidence against it. No evidence against it. Interesting. Well, let's talk for just a minute about some of the philosophy of science. And I know this is like eating your vegetables, but hang with me. We got a lot to cover, so let's go here, okay? Science comes from the word scire, the Latin. It means to know or to understand. Now, in science, we don't have absolute knowledge, but we gain understanding as we observe. Science is a process of investigation built upon facts demonstrated through experiments and observation in an effort to explain natural phenomena and natural law. Science includes observation, measurement, and testing. And a scientific theory is a testable and has been tested, at least to a degree. Now, this is where this professor apparently was a bit confused. Yes, there is some evidence for it, but it doesn't mean that there is no evidence against it. Now, what's a hypothesis? A hypothesis is an idea that is not proven, but that leads to further study or discussion. Scientific theories must be falsifiable. In other words, there's got to be some way, some test, that if it's not true, we could actually measure it and observe it. Science experiments must be repeatable from person to person. And natural law is a thoroughly tested and proven scientific idea. With science, we can make predictions. And it's through those predictions that we can apply science into our lives. Science is not complete. Science should always be open for more investigation. We should always be open to consider other ideas. In fact, science advances when someone else has an idea that they can show that the current ideas are not measuring up. They can falsify them or show challenges to them. And then they can, optionally actually, propose a new idea, a new theory that may better explain the phenomenon which we see. Theories that are not tested or are not testable are not scientific theories. And all theories, remember, all theories are open to scrutiny, and none are exempt from continued testing. And the objective of our science discussions should be to discover truth, to understand the essence or the origins of these cause and effect processes. Well, understanding some of these things, let's take a moment and let's look at the Big Bang Theory. Now, we understand, I think all of us understand to a level, what the Big Bang Theory is all about. There was some extremely large explosion in the far distant past, and in this extremely large explosion, after 20 minutes or so, matter started to precipitate out of that huge energy explosion. You know, there was an article published on the front page cover of phys.org magazine that no Big Bang, quantum equation predicts the universe has no beginning. challenges the Big Bang? Well, it's not just quantum equations. Fermilab, now Fermilab is one of the organizations that studies this idea of the Big Bang and does experiments to see if this really measures up. But Fermilab did this really interesting video in which they showed, one of the rare times, in which they showed actual challenges to the Big Bang. And the idea is that when energy comes out of matter, condenses out of matter, they come in identical amounts of matter and antimatter, two substances which will annihilate each other if they get in contact with one another. Identical amounts. Well, in the video they say, well, there's only one problem. We don't see any antimatter. It's simply not to be found anywhere. Naturally, the only antimatter we've seen is what we've been able to duplicate in the lab. So the fundamental prediction of the Big Bang is completely falsified. Oh, well, there have scientists who are trying to work on this problem, he admits, and they have some ideas, but really there's nothing on the horizon that really overcomes this fundamental challenge to the Big Bang theory. So how do we teach the Big Bang theory? You know, the recent science standards that were discussed, one of the board members asked one of the science experts, one of the guys who wrote the science standards or adopted them from the next generation science standards, and was a PhD, taught physics and science education in college. And she asked him, have you ever heard of any challenges to the Big Bang theory? What do you think? Well, I had actually given one a little bit earlier, so he couldn't say no, but this is what he said. I have not heard of any challenges to the Big Bang theory in scientific or in astronomical or physics circles. Nothing. Heard of nothing in contrary. And there's all kinds of challenges to the Big Bang. They're really everywhere. One of the challenges, kind of an extension of the Big Bang, is also the nebular accretion theory, in which the way in which stars and planets are formed. Mike Brown, who is a pretty well-respected astrophysicist, in fact, he's the guy, you can blame him, who demoted or got the process going to demote Pluto from a planet. So Mike Brown's well-respected in his ideas. And he says, before we discovered planets outside of the solar system, we thought we understood the formation of planetary systems pretty deeply. It was a real beautiful theory, and clearly, thoroughly wrong. And yet, you know what? They're still teaching it, and not admitting that there's some challenges to it. Still teaching it in our schools. So how did stars come to be? Well, let's take a look at how it's taught. I was on the science committee, and I hoisted up a few objections or a few concerns of the problems in science of star formation. And one of the professors on the committee got all upset, and he went to some astrophysicists at UVU, and here's what they came back to blast me with. He says, the theory of star formation is highly developed, well-understood model that is widely accepted by scientists around the world because it has been shown to be consistent with hundreds of different experiments. That is, star formation, is in no way considered controversial or speculative because it has been shown to be consistent with all observations to date. Wow, did they tell me? Well, I just went to a few experts who actually study some of this stuff in their field, and here's what they said. The very earliest stages in star formation process must consist of the condensation of a protostar from the interstellar medium. These stages constitute one of the most poorly understood areas in the whole field of stellar evolution. And we shall simply assume that a protostar has somehow formed. They go on in this chapter further. They say the problem of how interstellar gas and dust condenses to form protostars is one of the major unsolved problems of modern astrophysics. In this section, we'll only mention some of the difficulties. And we could go into those difficulties if we had time. And I'd love to share them with you because it's really cool stuff. But time doesn't allow us to dawdle very much, so on we go. They conclude with this. They said, we do not discuss these problems of condensation of gas clouds into protostars any further in this book. It is obvious that real stars somehow manage to come into being. Hopefully, we shall someday understand in more detail how they do so. But I can't help resist sharing just one more comment from a different expert, who said, if stars did not exist, it would be easy to prove that's exactly what we expect. So apparently, from the best understanding of our current science, stars and planets do not form naturally. There's big challenges there. Now, getting back to this professor who challenged me on, a scientific theory means there's no evidence against it. We were actually at the time talking about more biological evolution. And so let's consider that for just a few minutes. Now, biological evolution, of course, in the full sense of the meaning, is the common ancestry of all life in a purely materialistic origins for the observed existence of complex structures, systems, and organisms. Or in other words, let's make it simple, from the goo to you by way of the zoo. Okay? Everyone say it, from the goo to you by way of the zoo. All right, thanks. That's an easy way to put it out there. So what are the typical pieces of physical evidence that are usually pointed to as evidence of evolution? Call them out, just real quick. Vestigial organs, okay? Lucy, okay. So the fossil record, okay. Now we could go into all of these and talk about them in more detail. And in my little list here, you mentioned vestigial organs. I didn't include that in my list, but that's something that we can talk about as well. I have quite a discussion on that. But here are some of the ones that commonly crop up. One is the fossil record. That seems to be actually the first one that most people think of. Two is homology, or similar structures on living things. Genetics, similar genetics between various creatures. And embryology. Okay, the vestigial organs, that's a good one. I'll have to remember to add that back into this presentation. I had in some others. And the observed mutation in conjunction with artificial or natural selection. Now, you know what? All of these, except for the last one, are fundamentally challenged in their ideas. Now, the last one has been demonstrated, and we can observe and measure in the lab and also in nature. But it doesn't mean that there's a common ancestry of all life in that case. We don't have time to go through all of these, but let's just peek just a little bit at the first one, the fossil record. We look at these fossils and people think, wow, this is evidence for evolution. Well, I'm going to show you a few charts here, predictions of the various theories of origins. And in these predictions, we'll see which one actually measures up to the actual data. But to help you understand the chart, let's start with this. First of all, if there is only one kind of living organism, in this chart, there would be only one line that would persist throughout time. Okay? Easy enough? All right. Now, if evolution is true in this chart, you would see something like this, where you start off with one organism, and then it branches out, and then we have a couple more, and it branches out further and further, and so you get more and more diversity and complexity as time goes on, right? That's the idea. That's prediction of it, right? Now, if creation is true, if things were placed here on this earth, you would see something more like this, where you would see all things start at a particular time, and maybe some of them don't show up in the fossil record. Maybe that's true. And but yet they progress. Oh, maybe there's something that upset things, and changes the, maybe we lose a few phyla, very basic patterns of life. Now phyla, again, I use the term phyla, but it just means the basic body plans of life, okay? So the next chart is going to be the actual data from peer-reviewed journals of the latest stuff that we have. Is it going to show something like this? Now, it's okay if it's kind of jumbled up, you know, but if we see little variation and then a lot at the top, we'd get the idea. Or are we going to see something more like this? Okay, ready? Here it is, the real data. 1, 2, 3. What does it look like? Does fossil evidence show evidence of evolution? Or is it more in favor of a creation type situation? Yeah, exactly. Now we could go in and talk more and more about this, and I understand that some people may have different opinions than me. That's okay. Science isn't about having the same idea. It's about being open to the evidence, though, being willing to test the data. So we could go through each of these things. The fossil record challenges, from what I see. We could go through homology, genetics, embryology. They're all challenged. Darwin's theory is fundamentally challenged. It is true. Now, he was right at some things. He was right about finch beaks changing in relation to various conditions, and we could go through a number of things in which he was right, but this basic idea of common ancestry of all life and so forth does not fly. Some people may say, well, how come there's so much consensus out there in science, right? Well, this might help us understand a little bit. Science has an a priori adherence to material causes that produce material explanations, no matter how counterintuitive, no matter how mystifying to the uninitiated. Moreover, that materialism is absolute, for we cannot allow a divine foot in the door. Well, even people who believe in God have been caught up into this thinking that we cannot allow any divine or miracles. And here is a professor from one of our religious schools even, colleges, who says science has a non-negotiable stance of methodological materialism, which means no influence from God, angels or demons, no magic, no miracles. In fact, this was page 11 on my son and daughter's AP biology course, in which it said, the theory of evolution has also deeply influenced our way of thinking about ourselves. One reason is, of course, that it contradicts the literal interpretation of the Bible. Another difficulty is that it seems to diminish human significance. The new biology asks us to accept the proposition that we are not fundamentally different from other organisms, either in our origin or in our place in the natural world. Well, understanding is not enough in today's schools. Being able to understand the principles of evolution and be able to express those in a test or whatever is not enough. In fact, this is out of a paper that was written from professors at a religious university who said, knowledge of evolution does not appear to be equivalent to acceptance of evolution. Studies have demonstrated that religious objections to evolution are resistant to change even after thorough instruction. People have a right to hear both sides of the equation, don't they? Question mark. Careful analysis in this instance demonstrates that fairness does not apply. ID, or intelligent design, is a religious-based concept, not a scientific alternative. They go on to say, the evolutionary explanation for life origins does not require a role for deity. This is a religious institution. But there's no data that excludes that possibility. Well, has science lost its empiricism? Are we really not willing to test our ideas in the marketplace of ideas? Indeed, these ideas are, at very least, they're partisan ideas exhibiting blind prejudice. They're indoctrination, if we look at the definition of that. In fact, when we look at the legal obligation that children go to school, we could even call it brainwashing. Yes, indeed. I need to kind of move along a little faster. I have an hour and a half of stuff for you today here, guys. So anyway, but I want to talk to you just a bit about the peacock feather. Now, this is the reason why I do is because there is so much amazing evidence that there's more than material explanation in a simple peacock feather. In fact, Darwin said in a letter to Asa Gray that the sight of the peacock feather whenever I gaze upon it makes me sick. Now, interesting that he should say that. He also said if it could be demonstrated that any complex organism existed which could not possibly have been formed by numerous excessive slight modifications, my theory would absolutely break down. But I can find no such case. Well, maybe that's actually the reason why the peacock feather made him sick, and he wasn't really willing to admit it. The peacock feather actually is not colored with pigments. The peacock feather actually has an entirely different mechanism for creating colors. It turns out that if you take reflective surfaces that are very true and very carefully designed, and you put them very close to each other out near the wavelength of light, they'll reflect a certain color of light. And that's indeed what happens in a peacock's feather. Very controlled lattice smear surfaces. And by changing altering those, it changes the different colors. They do not come from pigments, as I said. In fact, in one of the scientific papers, it says color is produced by bouncing light between extremely closely reflective spaced surfaces. And now this is interesting how they said this. Coloration strategies in the peacock feathers are very ingenious. Interesting how they admit ingenious and simple, controlling the lattice constant and the number of periods in the photonic crystal structure. But it doesn't stop there. Take a look. Each individual barb that comes off that central stem on the peacock feather is like a string strung with little beads. And those little beads, the barb to the left of it is different than itself, and the barb to the right is different than both of them. But they all together create this huge symphony of amazing color. Well, to demonstrate this, I went down to the craft store and I got some little seed beads of various colors that are found in the peacock's tail. And I got a little plastic box and I dumped them in the box and we shake them up. And a peacock feather. Oh, no, you know that didn't happen, and it doesn't. You can shake this up time and time again. I don't get concentric circles. I don't get concentric squares. I don't get anything that really makes much sense. Now, is it possible? Yes, the probability is there, but is it so small that it is essentially impossible? And yes, and we can talk more about that probability. In fact, I'm writing a paper on that. Well, we need to move on here. We're just running out of time here. But indeed, the sight of the peacock feather did make Darwin sick, and there is every reason why it ought to make him sick, and everyone else who doesn't believe that there's a designer behind things. I'm sorry, that's my bias. It's my turn to shine here. He also was very turned off by the eye. But anyway, we need to talk about where we go from here. Well, I have started a few things to help share this idea. I can help in several ways. I can help in educational efforts. I can speak in forums like this or in homeschool where I can supplement there. We have presentations for homeschool in public. We have field trips that I can take your kids on and show them the marvelous things. Web resources. We have a couple of web pages. There's some mention of them on my business card. I hope you found my business card and keep those handy. We have a YouTube channel, Science Elevated and LDS Science Elevated. Fun stuff there. We are working with legislators and the state school board and even doing original research. Now, what can you do to help this effort? Teach your children. Be a mentor to your grandchildren. Find out what's being taught. to your children and grandchildren. Talk to teachers. Share with them that there's other ideas out there and people and resources to help share those things. Contact board members. Thank you, board member, for being here today. We really appreciate you and your hard work. She's on our side. She's wonderful. But we've lost a couple of board members, too, that were on our side. It's time to help make some friends with some board members. Get involved personally and or financially, and join the movement. Oh, movement. What's the movement? Well, there's so much amazing design. Well, we only talked about a small bit of a peacock feather. I could go on for hours about a peacock feather and the evidence for design in it. And we want to share that. You received a little sticker in your things today. If not, there's some more back there. And I want to get these stickers out to everyone who's willing to show the evidence of design. In fact, wouldn't it be cool if we had a bunch of students show up in class with a little sticker like this? Other students who are thinking they might bow under to the pressure, the social pressure of ignoring or being turned over to a materialistic mindset, may be willing to change their mind. So we have those stickers, and if you would like to get some more, we have more. If you would like to donate to help get some of these stickers out, there's a little donation jar in the back there. So really, all we have to do is just look around. There is evidence for design all around us, indeed. And in fact, just as is written in the Bible, yes, the creation of the world is clearly seen by the things being understood by the things that are made. Thanks, guys. Please get a hold of me. I'd love to talk to you more.